Well, hello, everyone. Welcome back from lunch. If you weren't aware that lunch just happened, I'm very, very sorry. There's still some over there. I just imagined hearing that, and everyone feels satisfied and satiated around you, and you're like, wait a second, I didn't even? Okay. So welcome, everyone, to the 5G Summit. Hopefully you're enjoying your day so far. How many of you were here on Monday? Anyone here joining us on Monday? Okay, fantastic. And then yesterday, a full day. We had our keynote to start off the day, many great sessions, and then a nice social fair carnival-like gathering last evening. Very cool. And then today, we've already had a very busy morning, but everyone is ready for the afternoon, yes? Whoa. Okay, cool. We're going to get started in just a moment. This is the technical track. Next door is the business track. So if you're looking to go to that side, you can bop back and forth. Last hour, we were talking about 5G and Wi-Fi and their intersection. We were talking a lot about fixed wireless access. And over next door, they actually had a business case for fixed wireless access. But the good news is you don't have to miss anything because all of these sessions are being taped and you can access them on YouTube on demand. So if you want to look up anything after the fact, rewatch something, watch something that you didn't have the opportunity to attend, it is all available to you at your fingertips. Probably thank you to Qualcomm for that. Okay, so we're going to get started with our next session here at 1. It is Accelerating 5G Networks with Open RAN, and we are going to be joined by our VP of Product Management. Please give a nice, warm afternoon welcome to Yongbin Wei.
All right. Can you hear me now? All right, good. Everybody had a good lunch break? Fully caffeinated, ready to go? All right. So I was talking to my colleague earlier today. My job is pretty easy. So at the end of the session, if you are not fall asleep, well, I did my job. But based on the survey just a moment ago, just listen to the response. Now you got me worried. So we'll see. So yeah, in the past 2 days, there's a lot of talk about 5G Open RAN. So in this 20-some minutes, I'll give you, I guess, 2 parts. One is, what is Open RAN, and why Open RAN can be relevant to your business. And 2, I'll try to introduce you our 5G RAN platforms, and try to do the sell pitch to you so our platform is good for your business, your product, your deployment. So let's get started. All right. So we're going to first, go back a little bit of, I would say, for some of you, the memory lane of the whole cellular history. So for a very, very long time, if you look at the cellular network, it looks like what you see on the left-hand side. So you have a core network somewhere in the data center, then you have the base stations. And between the base station, you have your backhaul. So everything, for a base station, for cell site is located everything for cell site is located at base station. You have radios, you have a baseband unit or BBU. Now, somewhere in the middle of LTE era, we start to see a new or different architecture where the BBU part of base station get pulled from the cell site to some centralized location. And between the radio and the BBU, you have the front haul, what do you call the front haul, but typically is the high-speed fiber. And that is, on that front haul, you carry all the IQ samples between the BBU and the radio. So that's the different kind of architecture. Many times it's referred to as a central RAN, right? Somewhere in the past couple of years, there's a new kind of architecture emerging. People are thinking about that. In this case, the radio access network, or the RAN, I forgot to mention that, now can be break up to 3 parts: the RU, or radio units, the centralized unit, or CU, and somewhere in between, you have the distributed unit. So where do you put all these different parts or that? It depends on, the situation. Obviously, for the radio unit, you put at the cell side, you put on the tower, and so the CU is typically in some kind of centralized location, and DU is somewhere in between. And another thing about this new architecture is now between the CU, DU, and RU, you have the open interface. So we talk about, backhaul in the old days, the front haul for this different architecture. Now you have a middle haul, which is between the DU and the CU. So behind all this, thinking is with this kind of architecture, it can bring in some benefits, say faster 5G deployment, make your 5G network deployment more easier to scale. It can support different multiple services, support different kind of deployments, and also has a potential to cutting down the cost. So those are the grand vision with this new architecture. Now to just dig a little bit deeper, let's take a look at this picture. This is from very high level. This is a 5G cellular network. And the left-hand side, we have the core network, and you have the radio access network to the right. Just like 3G, 4G, 5G, a radio access network typically have multiple protocol layers. So this is actually an example for 5G. You have the PHY, which is a physical layer. You have MAC, ROC, PDCP, and SDAP. So those are different protocol layers. This is all part of the air interface. For a very, very long time, I don't know how long ago it was, the way that people build the base station is you take all these protocol layers, but they're essentially vertically integrated in the same box. And that actually is the intention when the air interface is defined. Everything is, even though they are logically separated from each other, but really they are not meant to be built in separate kind of boxes. So that has been going on for a very long time, and that model works fine because back in the old days, the cellular service and the deployment is largely homogeneous. So that works fine. But as we went to the second half of the LTE deployment now in 5G, the cellular deployment become a little bit more, I would say, heterogeneous. Now you have indoor, outdoor, you have public network, you have private network, you have millimeter wave, you have sub-6. So those are pretty diversified deployment situation you're facing. And two, the cellular service also become more diversified. In very, very old days, we only have voice circuit switching. 3G, 4G, we added data service. But those get more amplified. Now we have broadband, mobile broadband, we have IoT, we have ultra low latency, high reliability service, and so on and so forth. So the 5G service or the cellular service become more diversified. Now, with this kind of scenario, the industry came to a realization that the old model, one size fits all, wouldn't work. That's where they start to look at, okay, what should we do? Should we bring the RAN into different parts? So the whole notion of this, you might heard the terminology of disaggregated RAN, is you take all the RAN different layers, and you try to define the different parts so that you can build the whole RAN network. So with that kind of objective, 3GPP actually spent quite a long time to look at the different options. So there, when you think about how to split RAN, that brings at least two questions. I can think about. One is, where do you split? Aggregation, disaggregation. And two, how many parts should we bring the RAN into? So those are questions. So the 3GPP after spent a long, long time, I think they want to make our life fun. So they came up like different options, option 1 to option 8. So take the example of option 2, that defined the boundary between ROC and PDCP. And for this kind of boundaries, there is open interface defined. That is a 3GPP F1 interface. The other option is option 6, and that defines the boundary between the physical layer and the MAC layer. So in this case, 3GPP didn't define the open interface, but small cell forum defined the interface, which is the FAPI interface. The other option, if you follow the Open RAN, you probably heard the option of 7.2. For that option, the physical layer actually got split into 2 parts, the low-fi and high-fi. So the high-fi stay in the, away from the radio. So either at the bottom of cell tower or in some kind of data center. And then you have the low-fi, it actually go together with radio. That can be deployed at cell site, sometimes even at the top of the tower. So the thinking of this split of the PHY into 2 parts is once you deploy the low-fi at the cell site or even at the top of the tower, you don't want to touch that frequently. And the functionality carried inside of the low-fi actually doesn't require the kind of frequent change. So on the other hand, the high-fi, you can do a lot of changes. So that's the thinking behind this option 7.2 split. So that's like, different kind of option to do the split. The other question is, how many parts should we bring the RAN into? There, I think there's, again, we're going back to the question of diversified 5G service, diversified network deployment. So how many parts to split into? There's no simple answer. So every time we have discussion and answer, so it's okay, it depends. Obviously, it's not a good answer, but actually it reflects the complication of reality, which is just because of different network topology, one model really doesn't fit into all the situation. So there, I think we probably can think about break the RAN into different categories. You have the one part, what I call the one-part solution. You have the 2-part solutions, and also the 3-part solution. So by one-part solution, what I mean by that, we are going back to the old model, which is all the protocol layers for the RAN, you put in the same box, including RF, including antenna. And you're probably going to say that for the so-called all-in-one cells, right? So that's the one-part solution. Now, for the 2-part, I think there are different variants. At least I can think about 2 variants. So one is, so this, based on the option 2, so you split the RU with ROC all the way back to RF antenna. On the other side, you have, PDCP and SDAP. So that is, one variance. You're probably going to say that for, say, if you have distributed small cell deployment, you probably see this kind of split. Basically, DU include everything, RF antenna to ROC, and the other part. The other variance for the 2-part solution is you follow this option 7.2 kind of split. So you have a radio unit that has the low-fi and RF and antenna, then everything else on the other hand. So now you no longer have like separated DU and CU. Basically, DU and CU kind of collapsed in the same box. So that's like 2 variants I can think about for the 2-part. Obviously, the typically people talk about a lot nowadays is the 3-part solution. You have the RU, again, that has the low-fi, all the RF antenna and stuff. You have the DU that has the hi-fi, MAC, ROC. Then you have the CU, which is PDCP and above. So all different kind of options. Now, so going back to I guess early we talked about the objective or motivation for the Open RAN. Is, oh, by the way, before I forgot, so for the option 7.2, again, there's also an open interface. In this case, the O-RAN Alliance defined open interface. It's called the Open Front-Haul Interface. I guess in this slide, it has the CUS, control plane, user plane, and a synchronized plane. So that's also, again, an open interface. So obviously, with open interface between different kind of parts of the radio access network, you can take basically a solution from different vendors and put together your overall RAN solutions. So that's the motivation of the Open RAN. So we talk about the benefit or objective of Open RAN. So really, if I can summarize a sense of disaggregated RAN into different parts, and also with open interface. Sometimes I think about this as more like a modular RAN design. If you are software engineers, or if you are industry design engineers, this probably sounds familiar. But really, with the modular RAN design, we can put basically different part of the RAN processing to the place where it is mostly suitable for that part of processing, right? So, just looking back at the CU, DU, RU kind of split. So the RU obviously is for radio. We involve RF, so it's best put it on the cell site and towers and so on, right? That's the RU. Now, if for some of the deployment, take the DU, because they are disaggregated from the RU and from the CU, you can take the DU processing from multiple cell sites and put in centralized locations. Now, with that kind of centralization, you open the door for a lot of the great things, right? So one example, because of all the DU processing for multiple cell sites are centralized in the same location, we can do, say, joint max scheduling. So you can look at all the users from different cell sites. You can do joint scheduling. Because they are in the same spot, we actually even share in the same resource, right? Computation resource. The other thing we talk a lot is so-called resource pooling for DU. What that means is if this DU, centralized DU processing spot handling the multiple cell locations, they don't necessarily have the same kind of cell load. So some might be high, some be low. But resource pooling, what I mean by that is you kind of even things out. You don't have to design for the peak. So that's the resource pooling. The other benefit about this centralized DU is unlike every cell does its own DU, now you actually can do a lot of advanced features that involve multiple cell sites. Example, some of the advanced features like multiple TRP. That's we have the advanced feature since release 15. We can do joint transmission. You might have heard of that as part of the network MIMO. The other thing about this centralized DU is, I didn't mention that in the previous slide, is now you have the centralized DU dealing with multiple cell sites. We can even connect a near real-time RIC, or the radio intelligent controller, at that spot to do all the cross-channel, cross-cell site kind of management, optimization. You can run machine learning. You can run your data analytics, those kind of things. So there's a lot of benefit if actually can centralize the DU processing for multiple cell sites. So that's one benefit of this kind of architecture. The other one is because we disaggregate the RAN into different parts, it makes it easier to build out your network. It's easier for scalability. Say, example I can think about is, say you build a network. Very beginning, maybe your user penetration is limited. Then you don't have to basically deploy a network with your peak demand from get-go. You can start with deploy your network with limited CU or DU capacity. Now, as time goes by, you have more users getting into your network. Then you can beef up your CU DU capacity without touching anything else. So that's the beauty of set the RAN network into different parts. One more benefit that probably involved this heterogeneous multi kind of network topology. Take the example of wide area network. That could be your national network, could be your regional network. There, I think this three-part solution we talk about probably makes more sense because you can have RU, obviously, at the cell sites. You can have your DU centralized into some kind of regional data center. Then you can have your CU is either further into the network, centralized in some kind of regional or even national data center. So that's kind of the one topology for wide area network, what I call it. Now, if you look at the other example, you have, say, a private network, a localized network. And there, maybe you don't need like the three-part kind of disaggregation. Maybe two-part is good enough. So you can put your RU, for example, your campus network, at the different cell locations. You have your high-speed fiber. You connect everything back to on-premise server room. Then you have your DU, CU kind of sunlight in that server room. In that case, only you have different topology. So again, disaggregation of CU, DU, RU give you different options, depends on your network topology choice. And that choice can be based on performance that you try to optimize. It could be based on the cost you try to minimize, or it could be based on the flexibility you're looking for. So it just gives you all the options. One more thing about this benefit of O-RAN is about the multi-vendor solutions. So because of you separate the RAN to different parts, and you have the open interface defined between the different parts. So now you actually can build your RAN network with solution from different vendors. So that's good for broaden the ecosystem, and it's good for generating more innovations. So that's all good. By the way, I should mention, having multiple vendor solution is nothing new for the core network guys, because they have been doing that for ages. It's just now with the Open RAN, we can do this for the radio access network. Okay. All right. I think I spent a lot of time on this slide, but if I have been thinking about what is a good analogy to talk about the Open RAN. Or the RAN disaggregation. I try to explain to my teenager son, the best example, maybe not a good example I came up is like Lego blocks. So you all play with Lego blocks. So with just a few, say, distinct shapes, people can build very sophisticated architectures. It can be like a very simple car to your Star Wars gigantic, Lego builds. So imagine that with Open RAN, disaggregated RAN and Open RAN interface, we can build all kind of 5G network, meet all the different kind of requirement, deployment scenarios. So I think there's a lot of potentials ahead of us. So I hope I gave you kind of a quick overview of what is behind Open RAN, and hopefully, that is something useful. Now, let me move to the second part, which is Qualcomm's 5G RAN platform. Again, because of the broad range of base stations we're dealing with, so our portfolio actually has multiple product lines. So for the small cells, the small cell could be indoor, outdoor, residential, or enterprise. We have our FSM product lines, FM100 and FM200 series. And those are great for small cells. For the micro or macron base station, we have our QRU100 and QDU100. Those are baseband chips. As the name suggests, QDUs for the DU and the QRUs for RU products. To save some, our customers some trouble to do its own card development, we actually took another step, which is we took the QDU100, that's the baseband chip. We actually developed a PCIe card. It's called X100 acceleration card, so that people can take this, put it into your server, and then you have virtualized DU product. So you don't have to go through the trouble to deploy to develop your own acceleration cards. All these products, I mentioned only the baseband part. Obviously, our platform is modem RF. So there's a companion RF solution as part of the platform. So sub-6, we have our RFIC, or RF transceiver for sub-6. For millimeter wave, the platform also includes a module that has the RF transceivers, has the RF component, and also the antenna arrays integrated as part of the module. So you can take that module for millimeter wave, build big antenna arrays for beamformings and so on. So that's the Qualcomm's RAN platform. I should mention that this is an important one. We are not have the plan to become like infra vendors. There's a lot of great companies doing that already. We don't need to do that. So our goal actually is to provide the top-notch modem ARF solution to our customer so that they can build great infrastructure products. This is just to illustrate that example. Say they can take our FSM products I just mentioned to do very power efficient small cells. Could be indoor, outdoor, residential, enterprise, like I mentioned. And this product can be so power efficient that you don't need like separate power. So the power over Ethernet is good enough to power those small cells. They can take our, say, QRU100 solution to build all kind of RU products for sub-6, millimeter wave, for non-massive MIMO to massive MIMO radio products, for very low transmission power, say they are micro kind of RU, to macro, very high transmission power, 70 plus dBm kind of products. This is all possible. Now, for the QDU, like I said, you can take our X100 card, plug in your server, and then you have a great virtualized DU products. So those are all the possibilities. All these, the different kind of products, they are fully O-RAN compatible. They are very flexible, can deal with all different kind of products spec you might have in mind. They are fully, like I said, it's fully Open RAN compatible. It supports all the global bands for sub-6 band, for millimeter band. So if you are targeting global market, those are great. Now, one more important thing I want to emphasize is, which we actually spend a lot of time to think about, is power efficiency, power consumption. What I mean by that is power efficiency. What is the performance? And how much we can integrate things into our products. So obviously, Qualcomm with our decades-long R&D on wireless communication and low power modem. So our products are super power efficient, has very high performance, and those are, we spend a lot of time to think about those things. So maybe there's a kind of perception in the industry that Open RAN products might not have good, high performance. We think our product is going to change that, right? Just kind of illustrate this point that our product portfolio cover broad range. So it really can target all different kind of deployment scenarios. Could be public network, shown here. We could be private network or indoor, outdoor. And it support all kind of services. I mentioned the mobile broadband is, we talk a lot about that. We have a massive IoT we can support. And we also, nowadays, there's a lot of discussion about ultra reliability and low latencies. And that also can be supported by the product. So there's this old saying that it takes a village to raise a child. So I think we're trying to do that with our platform, with our partners, and to quote unquote raise the Open RAN ecosystem. So we have great partners we're working together with. With AEC, we're working with them to bring our QDU to their 5G open and virtualized DU products. With Mavenir and Rakuten Symphony, we are partnering with them to develop the 5G DU and RU for massive MIMO in our next generation products. Again, the target is to for the Open RAN 5G deployment. And similarly, we are working with Fujitsu. In this case, they are bringing our DU and RU product into their millimeter wave integrated products. Again, the goal is for Open RAN 5G deployment, and they are doing this as part of the NTT Docomo's ORAC initiative, which is a great initiative, by the way, to broaden the ecosystem. We are working with HP, one of our great partners, to take our X100 card to their next generation DU products. So just give you an example. Here's HP's DL100 server. This is the standard recommend one U kind of server. Has multiple PCIe card, so we can actually plug in multiple X100 card into that server. So this acceleration card, I didn't mention that, is it takes care of all the physical layer 1 processing or modem processing from your channel estimation, from encoding, decoding, MIMO equalization, beamforming, those kind of things, all taken care of by the X100 card. And because of that, you no longer need to burn any resource on the server side to do any of the layer 1 processing. So that's going to be very helpful to reduce the amount of computation that is required for the server. It could be reduce number of cores you needed for the server. And because of the X100 card is really designed to do all the modem processing very efficiently, so this also result like reduction of power consumption. Now, with this one, it actually also include like multiple front haul connector as part of the card, so that you no longer need to have a separate card or NIC card just for the front haul. So if you step back and look at the whole, say if you want to support certain network size, certain cell size, certain channels, because each of the server has very high capacity in terms of how many cells you can support, and it's very power efficient. So really you can reduce the total physical size you need at a data server to support such a thing. So that's a lot of benefit to that. So we did a joint study with HP based on certain network site and certain configuration, and the study shows that you can save up to 60% of the operator's total cost of ownership over certain years. And also, I mentioned the power consumption reduction. It actually can save up to 40% in terms of power consumption, which is nowadays a very big part of operators' operation cost. All right, this is my final slides. So in addition to the infra vendors, we're also working with a lot of global operators. Okay, yeah, in the North American, in Europe, and also in Asian market. So we think working with all our partners, we can drive the adoption of the Open RAN ecosystem. So that's all the things I have. So if we have been working with your company, we thank you very much. And we are really excited about our collaboration. But if you are not our customer yet, I think we should talk about it. I think there's a good chance you're going to like what we offer. All right, thank you all very much.
Yes.